Okay, good afternoon. This one is just another video. It's for the non-calculator sections of the free response for the calculus BC test. So we'll take a look at that. Okay. So for this one, for number 3, and the graph is given. So it's a graph of g. So the graph of the continuous function g, the derivative of the function f, is shown above. So the function g is piecewise linear from -5 to 3, and g of x, which is 2 times the quantity of x minus 4 square from 3 to 6. Okay, so this part of the graph right here. So if f of 1 is 3, so what's the value of f of -5? Okay, so now let's find out. So one thing that you guys need to do, so make sure that we do know the condition here, f of 1 is 3. Okay, so if f of 1 is 3, so by using the fundamental theorem of calculus, we do know that integrals from -5 to 1 of f prime of x dx, which is the same as f of 1 minus f of 5. So using FTC. Okay, so f of 1 is given already, so we just plug in a number, which is 3. Okay, so 3 minus, and then the rest of this, we just want to integrate that in order to find out what f of 5, so we want to integrate it from -5 to 1. Okay, so from -5 to 1 of g of x dx. So basically you just want to find out the area from -5 to 1 right here. So this one we do have a trapezoid, and this one here we do have a triangle. So finding the area for this from -5 to 1, so we do have, okay, let's find out the area. Well, I can cut it off if you want to. So the area from -5 to -2, so we do have looks like we do have a rectangle. Well, actually it's a square. So 3 times 3, but it's negative. It's under the x-axis. So then that part would be considered, I just cut it off here. So that's a square. So this part is what? -9. And then this one is the area of a triangle. So the area of this triangle here, which is considered 1/2 times 1 times 3, but again it's negative. So this part of the area would be -3/2. And then all the way to 1 here. And then the area for this triangle, this small triangle, so we do have 1/2 times 2 times 1, then that'd be 1. And then combine all this 3 area together, so we got -9 minus 3/2, which is -10.5 plus 1, so -9.5. Okay, so -9.5. Okay, so try to combine this all together. Okay, so one thing I just want to check here, so making sure that the area got to be correct. So -9, so -3/2, -10.5 plus 1. Okay, so -9.5. Not -9/2, but -9.5. So combine this together, so 3 minus -9.5, eventually you'll get 25/2. Okay? So then that'll be the f of -5. Okay? So again, so this one is just equivalent. For those you might be wondering, how do I set it up? Like 3 minus, well, because that f of 1 is 3 already, So f of negative 5, so kind of going backward to find out, what the rest of the area is. So that means we just subtract. Okay, so now the next part of this, evaluate the integral from 1 to 6. So evaluate the integral from 1 to 6. So basically we just want to add those area from 1 to 6. So this one's quite similar. So from 1 to 3, what is that? That's a square. So 2 times 2, then that'll be 4. Okay, right here. I mean, you can show the word if you want to. Definitely you have to show the process here. So from 1 to 3, so the area is 4. And then from 3 to, okay, so for the rest of this, from 3 to 6. So from 3 to 6, so basically you have to integrate it. So integrate that of g of x. So the function we have. So integrate that to quantity x minus 4 square, and then dx. And then you'll end up with 4 plus 2/3 times the quantity of x minus 4 to the power of 3 from, well, this one's from 3 to 6. From 3 to 6. So that equals, using f of tc, so 2/3 times 8. So just show all the word here. So 2/3 times -1, and then you'll get 10. Okay, so that's part B. And then for part C, so let's see what that is. So for -5 to 6, on what open interval, if any, is the graph of f both increasing and concave up? And give a reason for the answer here. Okay, so to look at the graph. So if the graph is considered increasing, so that means for the rate of change is going to be positive. And also concave up. Concave up, that means, well, it's not just, the graph is not just right above the x-axis, but also it's considered increasing curve, okay? So you can see that from 0 to 1. So this one is right above the x-axis, but also is considered increasing. So the way to describe it, so f is increasing when f prime or g is positive, and this occur when from 0 to 4, 4 to 6, and f is concave up when f double prime or g prime is positive, or when f prime or g is increasing, and this occurs when -2 to -1, well, -2 to -1, okay? But the one that we just need to find out is just consider increasing, and also is concave up. So as you can see that from 0 to 1 here, so the graph is right above the x-axis, so the rate of change is positive. And then derivative of this is going to be positive as well. If you take the derivative, the rate of change, So that means from 0 to 1 and also from 4 to 6. So you find out f is both increasing and it's concave up. Okay, so you have to describe it with using the first derivative tests and also the concavity tests. And then the last part of this, so f, well, let's see. Find the x-coordinate for each point of inflections of the graph of f and give a reason for the solution. So the point of inflection. So that shows the point of inflection, so that means it shows the concavity, either from concave upward to downward. Okay, so as you can see that right here, f4. So derivative of this would be considered negative. Derivative of this part of the curve right here would be positive. So it shows the sign of change. So from negative to positive, so that means it right here f4. So that would be the point of inflection. Again, the graph that's given, it's considered the first derivative. So if you take the derivative again, you'll get the second derivative. So again, this part right here, the rate of change, it's negative, and then the rate of change right here is positive. So for the point of inflection, it occurs f4. Okay, so now let's see what else that we have for the rest of the free response. Oh, the table. This one is one of the classic one. Okay, so now we'll look at the given table. So this one shows the time versus the meter, h of t. So the height of the tree at time t is given by twice differentiable functions, h. So where h of t is measured in meters and t is measured in years, select value of h of t are given in the table above. So use the data in the table to estimate h prime of 6. Using the correct unit, interpret the meaning of h prime of 6. Well, once you see that, it's just the derivative. So this one basically just the mean value theorem. That's what you need to apply. So S6. So it's S6. So that means the time we're using is right between 5 and 7. So we can say that h of 7 minus h of 5 divided by 7 minus 5, which is 2. So then that would be considered, well, at h of 7, then that's 11. H of 5, then that's 6. So 11 minus 6 over 2, then we got 5/2. So it shows the rate of change. And also you want to interpret the meaning for h prime of 6. So h prime of 6, so that means the height of the tree is growing at the rate of 5 meters of every 2 years at t equals 6 years. Okay, so this one, it shows the rate of change. So the height of the tree is growing at the rate of 5 over 2. Probably you want to put in a unit, 5 meters for every 2 years at t equals 6 years. Okay, so now let's see what else that we have for the next one. Explain why there must be at least one time from 2 to, can I see that? Sorry. To 10. Such that h prime of t is 2. Okay, so for this one here, so again, it's all about the mean value theorem. So as we can see that from h of 5 to h of 3. Okay, so h of 5 to h of 3, so you have to pick the number. Okay, so this one is showing that 2, so we need to find out the rate of change. It's got to be 2. So we need to find out the interval. That's kind of getting close to 2. So you have to pick the number and test it in the interval. So the one that I would select for part B, so this one, it's h of 5 minus h of 3. So 5 minus 3, then that'll be 2. So h of 5, which is 6. 6 minus 2, then that's what? 2, so then that's 4. So it's 4 over 2. Then that'll be 2. Again, it's all about the mean value theorem. And also you can state that, and we know that since h is differentiables on 2 to 10, and h is continuous on 2 to 10. So that's just the requirement for the mean value theorem. So we know that h is both continuous and differentiables on 3 to 5, the interval, by the mean value theorem. So we know that there must be at least t on 3 to 5. So right between 3 to 5 right here. So such that h prime of t equals 2. And once such value exists on 2 to 10. Okay? So since we can find one value, so that means that exists right between the time interval from 2 to 10. So just state that the requirement for the mean value theorem. So again, the point is state that h of t is differentiable, it's continuous. And also we can find that h of 5 minus h of 3 over 5 minus 3, it's exactly 2. So that exists one value like this for the rate of change. So that means it happens in the interval from 2 to 10. And then for part C, you want to use the trapezoidal sum with the 4 subinterval indicated by the data in the table to approximate the average height of the tree over the time interval from 2 to 10. So this one you want to use the average value theorem. So we do know that it's 1 over b minus a, so it's 1 over 10 minus 2, and then integrate it from 2 to 10. So that's just the average value theorem for the integral. But now for that integral, we need to use the trapezoidal rule. So 1/8, so that's just the time interval, the average value. And then we're using the trapezoidal formula, so it's 1/2 times 1, because that the time interval from 2 to 3 is 1. And then from here, from 2 to 3, so we do have 1.5 plus 2 for the first trapezoid. And then for the next interval here, you want to use that as the lower base for the new trapezoid, so it's 1/2. So the time interval from 3 to 5 is 2, so 1/2 times 2, and then times 2 plus 6. And then you do the same thing for the rest of the interval here, so 1/2. So the time interval from 5 to 7, that's 2. And then, again, this column, we need to use that again for the lower base. So 6 plus 11. And then the last one from 7 to 10, the time interval, then that would be what? 3. And then we have to use what? 11 and 15. Lower base, upper base. And then once you accumulate this all together, combine them, and then you'll get 263 over 32 meters. Make sure that you have to show the word for the evaluations, okay? So this one is just time consuming, so that's why I just put it this way. So the last part of this, the height of the tree in meters can also be modeled by the function g, and given by g of x equals 100x over 1 plus x, and where x is the diameter of the base of the tree in meters. And when the tree is 50 meters tall, the diameter of the base of the tree is increasing at the rate of 0.03 meter per second. So most likely it's going to be like a related rate. According to this model, what's the rate of the change of the height of the tree with respect to the time in meter per year at the time when the tree is 50 meters tall? Okay, so the height is going to be 50 meters tall. And the rate, it shows that dx over dt. So what I'm doing here is just an annotation. So which is 0.0, whoops, excuse me. So dx over dt, so that would be 0.03 meter per second. So this one I'll just put in dx over dt right next to it. Okay, so basically this one we can just start it with g of x. So which is 100x over 1 plus x. And then you take the derivative with respect to the time, so dg over dt. So got to be careful, we need to take the derivative with respect to the time. So we need to take the derivative of x implicitly. So we'll get 100 times dx over dt using the quotient rule times 1 plus x minus 100x times dx over dt, because derivative of x right here, all over the denominator quantity squared, so 1 plus x quantity squared. And then the rest of this, you just need to plug in a number. So after you simplify the whole thing, if you try to simplify this whole thing, you'll get 100 over 1 plus x quantity squared times dx over dt. So basically I just combined the like term and take out that dx over dt on top, because that's the greatest common factor. So one thing that we noticed, so for g of x is 50, Well, how do I know? Because that when the tree is 50 meters tall, so the diameter of the base of the tree is increasing at that rate. So for dg over dt, so by plugging a number, so 100, excuse me, so 100 over 1 plus 1, because the diameter of the tree, well, x is the diameter of the tree. Quantity square times 0.03 meters per year. So eventually it's going to be 3 over 4. Okay, so this one is the related rate problem. Oh, the reason why that I get 1, okay, so let's see. Because that for g of x is 50, so you want to set that equal to, well, x is not 50, excuse me. Sorry about that, I was supposed to put in g of x. So for the height of the tree, because that's the height of the tree, is 50 meters, so you want to find out what x is. So because x is the diameter. Okay, sorry about that. So x is the diameter, so in meters, so it's 1 meter. If you just set these two equations equal to each other, so you solve for x, so you'll get x equals 1. So that's why I got 1 right here. So 3 over 4, and that shows the rate of change. So how fast the tree grows, the height of the tree is growing. Okay, so now, and this is the 1, okay? So 2 problem for the calculator one, and then 2 problem for the non-calculator. And then the next one, it's a polar, and I don't think this one is going to be on the AP test, because that, they're saying sequences series is being cut off, polar is being cut off. So again, so the regress of the test. So instead of giving you those type of a new topic for the test, they're going to raise up the regress for the optimization problem. They probably give you like problem regarding related rate, the one that we did. What else? Linear approximation. Okay, so and also some kind of word problem like finding the distance, displacement. So you guys want to watch the video that I put up on the YouTube channel for distance displacement. So the difference of the distance and displacement is that displacement is about the position of the particle. Distance is always integrals of absolute value of v of t. Okay, so you got to be really careful to find out the time interval because you want to separate them to integrate it. So I think those are the ones going to be on the free response, okay, for the BC test. Besides this, and also it's going to be like maybe one problem regarding the integration technique. Okay, so watch out with those type of problem. Okay, so and study all the things that you learned already. Again, so watch this video and also the previous one and also the one that I did with the AP Calculus students for the on the Zoom meeting. Okay, so I'll see you guys next time if we do have time to get one more practice video done. All right, good luck on your tests. Take care.